Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Syed Akmal bin Syed Jamalil, currently a student from Faculty of Electrical Engineering and Technology, University Malaysia Perlis. I would like to thank the organizer of ICSET 2023 for giving me the opportunity to present my project today. The title of the project today is the development of second order high frequency filter for partial discharge measurement. Here is my team member, Ms. Zalika, Professor Muzame, my supervisor, Dr. Zaidi Abdullah and Dr. Ayub Nayan. Okay, here is my presentation structure. As we go to the presentation, I will explain on each section. Okay, here is the introduction. The high frequency PD measurement can be affected by the noises interference from the sources like electromagnetic interference and the background noises, or we call it white noises, ranging between the 20 Hz to 20 kHz. So designing an effective filters for a high frequency PD measurement is challenging. So today I will present a second order Butterworth Sallen-Key high pass filters to overcome the problem. So the main objective of the research is to reduce the interference noises that interferes with the PD measurement. So we do not want the low frequency noises, so we have to cancel it out. So how to cancel it out? We have to make a filters. What is the suitable filters? The suitable filters is the high pass filters. And what is the novelty of my project? My project will present the second order of the high pass filters with a higher bandwidth. And because of the PD signal frequency range from 1 MHz to 1 GHz, so this filter has to be designed with a high cutoff frequency. In my case, in my project, I will design my filters in at 500 kHz cutoff frequencies. So what is the problem statement? Here is the problem statement on my projects. The first will be the inaccurate PD measurement. The high pass filters are designed to attenuate low frequency signals, which may include the noise interference or the interference. However, if the cutoff frequency is set too high, it can also attenuate the genuine PD signals. So we do not want that. So that's why we have to know what the range frequency of the white signals and what is the range frequency of the PD signals. Okay, the second problem statement will be the signal distortion. If the filter is not properly designed, it may introduce the phase shift and the amplitude distortions. And the third one will be the optimal filter and the op-amp selection. This is most the crucial part. We have to select the right op-amp, and in my project I will using the Max 4412 op-amp. Is the low voltage op-amp and very cheap. The fourth one will be the filtering non the PD signal. High pass filters are intended to remove the low frequency noise, but they may inadvertently filter out the non-PD signals. Okay, so we do not want that. And the last one will be the filter stability and maintenance. So we have to design with the active filter, not the passive filters. Okay. The objective, the first one will be designing the second order Butterworth Sallen-Key to eliminate the low frequency components. The second will be to maintain the integrity of the signal, so we do not want our signal will be the phase shift or the amplitude shift in the output signal, and the last one will be the enhance the sensitivity of the PV signal. That's why I'm designing this high pass filter using the PCB. Okay, so this is the scope and delimitation of my project. The first will be the signal attenuation. The high pass filter will be set to 500 kHz cut-off frequencies to balance the noise reduction with preserving the PD signal integrity. The second one, we have to follow the IEC standards to measure, because in order to get the right PD measurement, so we have to follow the IEC 60270, which measures PD's pulses from the high voltage underground cable with the frequency range bandwidth around 500 kHz to 50 MHz. And the last one will be the sensitivity to the cable. The effectiveness of the measurement on the PD signals using high pass filter can be vary depending on the specific configuration. So we have to follow the IEC standard. And for my project, I will be focused on the underground cable 11 kV, because that is the most common type of the high voltage cable used in Malaysia. Okay, this is my methodology. First, we will determine the requirement and specification of the HPF, and then selection of the topology. In this case, I'm already told you we are going to use the high pass filters with Butterworth and Salem key. And then next one will be design the filter order. So in my project, the novelty of my project is using a second order Butterworth high pass filter, because usually the other researchers will making the low pass filters and the band pass filters. So I'm designing high pass filters with the second order Butterworth Salem key. And next one will be determine the component values and they simulate using a Proteus and the other softwares, and then determine the requirement and the specification of the high pass filters. And then we are making the prototype using the PCB. Then the project will be tested on the HB lab and making the iteration and refinement to get the better result. Okay. Okay, this is the prototype. As you can see, this is a PCB that I already made, and we make two versions of this. The last version is quite not using the proper design, so I'm making this is the second version, and I'm improving this version. So I'm making the third version now using the standalone battery, because this one I'm using supply 5 volt from the battery, from the power bank or from the 5 volt sources. Okay, so this is the design that I already made. Okay, and the results. This is from the Proteus. The simulation of the high pass shows the frequency of 500 kHz. Okay, from the calculation we set the cutoff frequency 500 kHz, but it is important to note that the drop in dB does not necessarily imply the malfunction or error. So if we see our high pass filter here, 500 kHz is in the acceptable range. So the design is quite good, because I want a 500 kHz, and then we get between 500 kHz to 700 kHz. It is acceptable range for the design. And after this we should look at the the prototype and we can compare with the simulation. Okay, this is the result performance of the filters. We are using the function generators and the oscilloscope. I'm not showing all the results, but this is only to show that when the input signal is higher in the range of, we call it a high frequency signal, it will pass the signal at the output. So we don't look at the voltage, we look at the output of the frequencies. So the high pass filter will pass all the high frequencies. Okay, but in the lower frequency input, so it will attenuate all the white noises. So that's why we see there are no signals if we produce the input with the lower frequencies. Okay, so it shows that the high pass filter is quite good to pass all the high frequencies signal, but to attenuate all the low frequency signals. So here is the frequency response from the prototype filters. So we can see even though the frequency cutoff not getting the 500 kilohertz, that will be maybe on the component tolerance. Okay, so we cannot get all the exact amount of the cutoff frequencies from the simulation with the actual one, but it was in the acceptable range. So we can use this result as the good result because the main function of the high pass filter is to attenuate all the low frequency filters. So we can see all the frequency filters lower than 1 megahertz will be attenuated, and all the frequencies higher than 1 megahertz will be passed. Okay, good. So this is the good result. So this high pass filter will be tested on the PD measurement on the underground cable with the underground cable. So this is the results. So if you can see the PD signal without the filters, it produce interferences, but once we put it the high pass filters at the measurement setup, so we can see that second order high pass filters will decrease from will attenuate all the white signals, and the PD signal decrease from 123 millivolt to 67 millivolt. So it will show the true color of the PD signal. So we don't have to analyze with a very hard way. So we can see all the PD signals are already shown without any further analysis. But we need of course we need to do the further analysis. So I just want to show that the high pass filters that we designed able to attenuate all the low frequencies. So it already proved by this result. Okay, so for the conclusion, it can be concluded that second order HPF is made to pass the higher frequencies while attenuating the lower ones. The prototype of the second order HPF shows the cutoff frequency of 1 MHz. There are maybe several factors that cause a slight differences between the simulated and the actual values, but it was in the acceptable range. Okay, and when the PD testing is carried out without the HPF, the PD signal and the ground cable will include all the signals. We can see all the interferences, noises, but when the HPF is applied to the setup, so we can see the voltage ripple is reduced from 123 millivolt to 67 millivolt. So it proves that our design is quite good, and we can use this design to make it more reliable. Maybe next time we can use the adaptive noise cancellation with the dynamic noise cancellation. So that is for the future work of these high pass filters. So that's all from me. Thank you very much. And if there are some questions, you can email me. So I will try to answer about my project. Thank you very much.